Good day, my angels. This is the solution key for quiz number 2. For the last time this year. Here we go, mark your own. Number 1, what is the current and its direction through the 5-ohm resistor? Okay. Well, the key idea for Kirchhoff's rules is current in has to equal current out from this junction right here. So if I look at that particular junction, it looks like the current out is 0.75 amps plus 0.53 amps. So if I add 0.75 plus 0.53, I think it's 1.28, but let's double check that since it's a quiz. We'll make sure. Oh, looks like I opened a couple of calculators. How many did I open there? Okay, let's see. 0.75 plus 0.53. So I have 1.28 amps coming out. That must mean I have 1.28 amps coming in. Well, this is 0.96 amps coming in, so the current in the 5-ohm resistor has to be 1.28 minus 0.96. And I get 0.32 amps. 0.32 amps. Direction, if you said down or right or into the junction, something along those lines, I'd give you 1 mark for the magnitude and 1 mark for the direction. Number 2. 4 resistors and a 15-volt power supply are arranged to form the circuit as shown. Okay. I can already tell you that I'm going to have to rewrite this circuit because I don't know 2 things, 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 and I don't see current anywhere. So, here we go. These 2 are in parallel. So the first thing that I'm going to do is make a little note. 1 over R parallel is going to be 1 over 10 plus 1 over 10. So I can replace those 2 in parallel with 1 over 10 plus 1 over 10 is 2 over 10, so 10 over 2. I think 5 ohms, let's see. 10 reciprocal plus 10 reciprocal equals reciprocal. Don't forget to take the reciprocal of your answer. Yep. 5. Come on. Ohms. So, if I do a resketch, this is really the same as, do I have room somewhere? I didn't leave much room. This is the same as a 15-volt battery, a 20-ohm resistor, a 5-ohm resistor, and a 20-ohm resistor. So our total is going to be 20 plus 5 plus 20, 45 ohms. If you got that right, 3 marks. Otherwise, I would probably give you 1 mark if I saw that, 1 mark for that, half mark for adding them together, and a half mark for the answer. What's the total current leaving the battery? Okay, so now that I know R total, I total is V total over R total. V total was 15. R total was 45.33 amps. 1 mark for that. Half mark for that. Half mark for the answer. Now, if you got A wrong, but you went 15 divided by your answer from A to get an answer here, I would give you 2 out of 2 for part B. What's the voltage drop across R1? Well, I know the current going through R1. The current going through R1 is 0.33 amps. And so the voltage drop must be I times R. It's going to be 0.33 amps. Bear with me, I'm using a different electronic stylus than normal. 0.33 amps times R1 was 20. So 15 divided by 45, there's the 0.3 repeating, times 20. It's going to be 6.67 volts. 2 marks for that. I would give you 1 mark, half mark, half mark. Again, if you got your answer wrong in B, but you went your answer from B times 20, I would give you 2 out of 2. Number 3, I'm going to have to rewrite this because I don't see 2 things or current anywhere. So that's how you can tell at a quick glance whether or not I'm going to have to rewrite this. I forgot to label downhill, by the way, in question number 2, didn't I? I should have technically done that first. Label downhill. So, label downhill. Look for 2 things. Look for I don't have any of that. I'm going to have to rewrite this. So to find the terminal voltage, first of all, I'm going to have to find R total. These 2 are in parallel. So, 1 over R parallel, 1 over 10 plus 1 over 10. I literally just did a 1 over 10 plus 1 over 10. I remember the answer from question 2. So R parallel is 5 ohms. So that means that R total is 5 plus 0.7 is 5.7 ohms. So that means that I total is V total over R total, 15 divided by 5.7. Yuck, 2.63 amps. And so, the terminal voltage is going to be the EMF 15 minus the I times R in the little internal resistor, what I lose going through that resistor. So it's going to be 15 minus 0.7 times 2.63. minus 0.7 times, I'm going to use my answer button, and I get 13.2, I would take 13.1, 13.2 volts. If you got that, 4 out of 4. Otherwise, I would give you 1 mark if I saw that you had found R parallel. I would give you 1 mark if you had found R total, 1 mark for finding I total, and 1 mark for finding the terminal voltage. Suppose the 10 ohm resistor is removed. The terminal voltage of the battery will increase or decrease. Well, let's see. If I remove the 10 ohm, the bottom one, now I just have 2 resistors in series, so R total would be 10 plus 0.7, which is 10.7. I total will be 15 divided by 10.7, which is 1.4. The terminal is going to be 15 minus 1.4 times 0.7. And so the terminal voltage increased. The EMF can't change because that's constant. Now, the other way you could have said this is something like this. If you remove a resistor, Mr. Dueck, spell that correctly, in parallel, R total goes up. It's when you add a resistor in parallel, and although you're adding a resistor, it lowers the total resistance. So when you remove it, R total increases. So I total decreases. So since you're losing less going through the battery, the terminal voltage increases. I would have accepted the right-hand side because that's just purely theoretical, or you could just run the numbers. Number 4. Ooh, I'm going to have to rewrite this because I don't see two things anywhere. First, those two are in parallel. 1 over R parallel equals 1 over 16 plus 1 over 25. Our parallel is going to be Dueck. Well, okay, there's a 0 there. 9.7561 ohms. Our total is going to be 7 plus 9.7561 plus 1. That's really messy, Mr. Dueck. Dope. So it's going to be 7 plus answer button plus 1. 17.7561. Ohms. So really what I'm arguing is that this circuit can be rewritten as a 15-volt EMF a 7-ohm resistor, a 9.7561 ohm resistor, and a little 1. Let's leave myself a bit more room. A little 1 ohm internal resistor. Okay. I total equals V total over R total. So it's going to be 15 divided by 17.7561. 15 divided by answer by. And I get 0.84478. Amps. So that means I have 0.84478 amps going through here, and 0.84478 amps going through here, and the total of that going through there. Doesn't mean I have that going through each one. So I think my best bet is to go look at my sketch right here. I know that there is 0.87478 amps there, and 0.87478 amps there, and 0.87478 amps there. This is the interesting one, because that, I know two things. I can find the voltage. It's going to be that times I times R. So I is 0.8478, which I still have to start on my calculator, times 9.7561, and I have a voltage of 8.24176. 8.24176. 8.24176 volts, which means up here, each of these has to be 8.24176 volts. 8.24, let's do that on the other side, Mr. Dueck, so you have more room to write. 8.24176 volts. So this question wants me to find the power dissipated here. Well, I now know two things. It means I know four things. I can finish up by saying power equals V squared over R. So it's going to be this number squared divided by 16. And I get 4.25 watts. I'll go 4.2 watts. So if you got that, I would give you 7 out of 7. Otherwise, I would probably give you 1 mark for that, 1 mark for that, 1 mark for that, 1 mark if I saw that somewhere. That's 4 marks. I would definitely give you 1 mark if I saw that. That's 5. That's 6. Where would I give out my 7th mark, Mr. Dueck? I would probably actually give out my 7th mark just for seeing that 1 over R parallel equals 1 over 16 plus 1 over 25, something like that. So that, my angels, is the quiz. If you could give yourself a lovely score, please, on the top out of 23, and send me your quiz, or you can just email me your score. You're going to have a test next week, and I'll send you an email. I sent you information about the test actually in Monday's email. I included the ultimate review, and so I gave you some questions to look at. Basically, I'm going to give you 2 circuits to solve. One will probably not require you to rewrite it. One will require you to rewrite it. One of them will include an internal resistor, an EMF, and a terminal voltage. The other one won't.